Good afternoon, everyone, and welcome to our webcast series, 2021 NFPA 79 Updates. In these webcasts, experts from both UL and Eaton's Bussmann Series team take a closer look at the newest edition of NFPA 79, which was published earlier this month. My name is Shannon Stokes with the Bussmann Series team, and I'll be your moderator for today's webcast. Today's webcast focuses on machine supply circuit and disconnecting means. Our speakers are John Kovacic with UL and Dan Mieser with Bussmann. Throughout the webcast, you are welcome to submit questions for our speakers. We will try to give the last 15 minutes of this webcast to answering those questions. Any question that we don't get to by the end of the webcast, we will respond to all of them and send them to everybody registered for this webcast via email shortly after. Once we've ended this webcast, you will be able to view it on demand anytime within the same portal that you used to join us live. First up, I'd like to introduce Dan Mieser, Senior Field Application Engineer for Eaton's Bussmann Series Solutions. For more than 25 years, Dan has been providing technical guidance to consulting engineers, OEMs, electrical contractors, and industrial and electrical inspectors. He is sought after for his training expertise, particularly around SCCR. He participates in IEEE, NEMA, NFPA, UL, and IAEI panels and activities. I'd also like to introduce John Kovacic, Primary Designated Engineer at UL for Industrial Control Equipment, Components, and Assemblies, including control panels and industrial machinery. His 45-year tenure with UL has covered countless codes and standards and technical committees. He sits on NEC and NFPA committees and serves as Technical Advisor for the IEC. I will now turn it over to John. John?
Thank you, Shannon, for that kind introduction. And good day, ladies and gentlemen. Once again, it's a pleasure for me to deliver this webinar with Dan Mieser, my esteemed colleague from Bussmann. Well, I have good news for all of you, and this is something that you may be aware of. The 2021 edition of NFPA 79 was published on October 5th, earlier this month. I don't believe the document is yet available, but it is good news that it is ready to hit the streets. Those of you that are familiar with NFPA's standards change process will recognize that there were no appeals filed to challenge the work of the NFPA 79 committee, and therefore the document agreed to by the committee through the NFPA change process becomes what's called a consent standard. Let's take a moment to review the agenda for today's webinar. We have divided the program into three parts covering different areas of Chapter 5 of NFPA 79, which addresses a disconnecting means for a machine. In Part 1, we will talk about the machine supply circuit and the main disconnect for the machine, which is now referred to as the machine supply circuit disconnect. Remember that terminology, very important. The majority of the webinar will be devoted to this part of the program. In Part 2, we will cover additional disconnecting means for a machine. We will discuss permitted types of disconnecting means, their method of operation, which is a very important part of Chapter 5. In Part 3, we will cover means for removal of power. Removal of power is not only accomplished by a disconnecting means, but other devices which may not disconnect the source of supply from the machine. It's important to note that there was a major rewrite of Chapter 5 for the 2021 edition of NFPA 79. Being a very important chapter in the document, the committee decided that it needed some clarity with regards to arrangement and wording. And the committee spent a considerable amount of time completing the rewrite, and we hope users of the standard will find that it is an improvement over the manner in which the chapter was presented in the 2018 edition of the document. Now, as we move through the slides, you will see changes that occur in the chapter provided in legislative format. We've also highlighted the changes in red so that they are easily identified in the slides. And we have tried to highlight as many changes as possible. In many cases, you will see that there were no technical changes, but simply reformatting and rearranging for clarity and usability. That takes care of all the preliminary information we would like to share with you. So let's move on to part one. So how is Chapter 5 organized in the 2021 edition? The chapter was revised as a result of what is called a global public input. I'm sure many of you recognize what that is, especially being familiar with NFPA standards change process. It was a public input to identify 3 types of disconnecting means with specific requirements for each. There are 3 different sections that now represent the chapter. Section 5.1 provides the requirements for machine supply circuit disconnecting means. Section 5.2 provides the requirements for other disconnecting means used to enable work to be performed in a de-energized state. And then finally, Section 5.3 provides the requirements for means of removal of power for preventing unexpected startup of the machine. You might ask, since Chapter 5 deals with enclosure access, shouldn't this chapter address enclosure interlocking? Well, the committee decided that the enclosure interlocking requirements should remain in Chapter 6 and therefore did not relocate them to Chapter 5, feeling that Chapter 6 was the more appropriate place to address these as they deal with electrical hazards and protection from them. Additional revisions have been made in Chapter 6 to clarify how the enclosure access requirements are applied to enclosures containing the machine supply circuit disconnecting means and enclosures that contain other disconnects. We have another webinar coming up very soon covering Chapter 6 and the changes to that chapter for the 2021 edition. In that webinar, we will cover in details requirements for enclosure interlocking. This revision of Chapter 5 continues the work of the 79 Committee for the 2018 cycle regarding the consistent use of the terms machine supply circuit disconnecting means, and other important terms like plainly and clearly visible. So let's just take a look at what we're going to cover in part 1 of this webinar. We see in this slide all of the sections that we're going to address. First, we'll talk about a definition back in Chapter 3, which is very important, and how it relates to Chapter 5. Those of you that are familiar with the standard recognize that all of the definitions are in Chapter 3. And then we'll go through each of these sections you see in the slide, starting with the machine supply circuit, working through things like terminations and marking, backfed terminations, wire bending, and then we'll get finally into accepted circuits, and we'll talk about what those are and how to deal with those with regards to electrical shock hazards. Now with that, I'm going to turn the program over to Dan. Dan, thank you very much for joining me, and it's all yours.
Thank you, John. I appreciate that great intro to the presentation today. As you mentioned, Chapter 5 has significant changes to them. And we're going to have a good list of items to cover here. We'll be splitting these items up periodically, so you'll hear us pass the baton, so to speak, back and forth as we go through these. The first thing I'd like to talk about is, since this is on the Chapter 5 is focused on the machine supply circuit, I'd like to start with the definition. I'd like to note that this definition was actually new in the 2018 edition. Okay, so we have now correlated this with the changes made in Chapter 5 of NFPA 79. And what you're going to see is that the changes made throughout Chapter 5 are going to be a continuation of what we tried to do in the 2018 process. And you'll see that a lot of the changes that are being made is to clarify what we're talking about with regards to Chapter 5. And the primary focus of Chapter 5 is the machine supply circuit. So as you can see, the machine supply circuit is simply the conductors between the premise wiring and the machine supply circuit disconnecting means or terminals. In the first draft revision of the process, and as you, for those of you who are aware of the NFPA process, it actually is a two-step process. So you'll hear me talk about what we did in the first draft stage, and then what we did in the second stage, which is called the second draft. So if we didn't get it right in the first draft, there's an opportunity in the second draft to correct that. So as I go through these changes, I'll talk about what we did in the first stage, or the first draft, and what we did in the second draft. So in the first draft, as you can see, we revised the numbering due to other definitions being added, and added supply circuit for clarity. So again, whenever we want to talk about the machine supply circuit, we want to be using that entire term to be stated in the requirement. In addition of these words will be typically in other sections of Chapter 5, as you will see in the upcoming slides. So what we've done is you'll see throughout these slides I'm covering the addition of supply circuit in many cases, or perhaps machine. The purpose is to differentiate between the machine supply circuit, which are the conductors from the premise wiring and downstream equipment supplied from the supply circuit disconnecting means, such as what we might call perhaps a subpanel. As you will see, the requirements for the machine supply circuit can differ from other supply circuits downstream of the machine supply circuit. So let's move into Chapter 5. So the first section that we'll cover is Section 5.1. And as you can see, this Section 5.1 covers the requirement for the machine supply circuit and disconnecting means. And that was actually one of the changes that we made there. So we revised the title from machine supply circuit conductor terminations to machine supply circuit and disconnecting means, to identify that we are also going to cover the requirements for the machine supply circuit disconnecting means in addition to the terminations. As part of the NFPA style manual, it's usually good to have titles for sections. So as you can see here in the first draft stage, we added the title Machine Supply Circuit to Section 5.1.1 for clarity. And as you can see, this section limits the machine to a single supply circuit where practicable. Now, when we say where practicable, it's not where it's convenient. That's where it's impossible to necessarily do differently. So unless you can prove that it's impossible to not have only one supply circuit, you're not permitted to do that. Where the additional sources of supply are needed, these shall be derived from the devices on the machine. And what you'll also notice here, for those of you who perhaps are not familiar with the NFPA 79 standard, is you'll see an asterisk by the 5.1.1. Now, what that asterisk indicates is there is actually annex material that will provide additional information on why perhaps we might have to have another source of supply. And if we look into the annex material for this, it basically details that this might be required for large, complex machinery with a number of widely spaced machines working together in a coordinated manner. It also references the site supply circuit requirements in 5.1.9.7, which we'll cover coming up in this presentation. If we go to that section, you'll find out that that deals with enclosure access requirements for enclosures containing the machine supply circuit disconnect. And again, we'll cover that later in this presentation. The next section we're going to talk about deals with the machine supply circuit conductor separation. So it's very important. So when we have the wiring that's coming in from the premise wiring into the machine supply circuit, it could be terminals or it could be a disconnecting means. When that comes in to the section, we want to make sure we have proper separation. So as you can see here, section 5.1.2 covers the separation requirements for the machine supply circuit conductors, which, and as you'll notice here too, with the restructure of Chapter 5, we moved a lot of requirements around. So this is not necessarily new text. It actually existed previously in section 5.1.6. And again, you'll see that we've moved things around pretty dramatically. In fact, when we first did this in the first draft stage, we actually had kind of a spreadsheet that showed what was there and where it moved to make sure we didn't lose any requirements in this transition. So in the first draft session of the process of revising for the 2021 version, the section was titled, again for clarity, Machine Supply Circuit Conductor Separation, and the term machine was added in 3 locations, and the term machine supply circuit was added in 1 location, again for the purpose of consistency and with the use of terms. In the second draft stage, we added the text required and changed by the use of to with. So let's talk about this requirement. What is required? Well, the general requirements detail that the machine supply circuit conductors must be separated from other conductors. In the first subdivision, it requires the machine supply circuit disconnect to be near the top of the enclosure with the required wire bending space, which we'll talk about later in this presentation. In the second subdivision, it requires that the machine supply circuit disconnect is mounted at, if it is mounted at other than the top of the enclosure, a barrier separating these conductors from other conductors is required. So now that we've talked about the separation requirements for the machine supply circuit conductors, we now can go to the termination. So we're going to talk about what we have to terminate the wiring, the premise wiring into. And we have a couple options, okay? So if we look in section 5.1.3, this covers the requirements for the machine supply circuit conductor terminations. In the first draft stage, the term machine was added in 4 locations and machine supply circuit in 1 location, again, for consistency with the use of terms. Section 5.1 was revised to 5.1.3, and Section 5.1.4 was revised to 5.1.3.1 and titled Marking. And the term shall was added for clarity and consistency respectively. An example of acceptable marking was provided for additional clarity. And then in the second draft, we deleted machine supply circuit, which quite frankly, I believe we probably should have kept that. That was actually an editorial change, we're told. After we make changes, NFPA staff can go back and make editorial changes. In some cases, they added machine, for instance, where we forgot it. For some reason, editorial staff deleted machine supply circuit. I believe that would have been helpful to keep that. Terminals for, and then we also changed such as to example. So previously it said such as line 1, L1, L2, L3, and now we have changed that to example. So let's talk about what this requirement means. So basically this requirement stipulates that the machine supply circuit conductors must be terminated in the machine supply circuit disconnected means, again, where practicable. If we have to have connections to terminal blocks ahead of the machine supply circuit disconnecting means, those are permitted only for accepted circuits, and we're going to talk in detail about accepted circuits in the next webinar on Chapter 6 and electrical hazards, or where the machine supply circuit conductors are other than those identified for the disconnecting means. All terminals for the machine supply circuit are required to be marked. So if you look at the graphic to the right, what you can see there is we have a situation where we have some accepted circuits. So in order to have the ability to have the incoming machine supply circuit conductors terminate, we're going to have to terminate those into a power distribution block. From that point, we're able to tap off with those yellow wires and go to a disconnect that then supplies a control power transformer, which is required, as you'll find out, for accepted circuits, and then that can supply the accepted circuit load. From the power distribution block, we then would wire from that to the machine supply circuit disconnect. The last thing I'd like to talk about before I pass it to John is a new requirement that was added for backfed terminations. And this is very important to consider. The NEC doesn't talk very much about backfed terminations. It's only in a few certain applications, but this is really more of a proper listing and labeling requirement for the product. You know, one very important thing in the NEC we talk about is NEC 110.3b, which basically says you need to apply a product in accordance with its listing and markings. And as you can see, when we mark a device, a disconnecting means, such as a circuit breaker, for instance, or a fusible switch, if the orientation of the conductors is important, we're going to have to identify that, either with the terms L, line and load, as you'll see in the picture, or in the fuse disconnect, we can mark it L, which indicates the line terminal, and T, which indicates the load terminal. So we're going to make sure whenever we have these devices, we are going to mark those, we're going to terminate the conductors properly in accordance with those markings. So again, section 5.1.4 covers backfed termination. The added text addressing backfed termination makes it clear that a machine supply circuit disconnecting means that is marked with line and load cannot be backfed. Text has been added to identify the requirements for when machine supply circuit disconnecting means can be backfed, and for the marking requirements when it is backfed. Now, I'm sure you're asking, well, when do we have to mark line and load for a circuit breaker? If you look in the UL 489 standard for breakers, you'll find that a circuit breaker that is not marked line and load has been tested with the line and load connections reversed during the overload, endurance, and interrupting tests per UL 489. With regards to the fuse disconnect you see there, that is marked line and load due to the switch construction. In this case, the switch only disconnects the line side connection to the fuses, and as such must be marked line and load to assure the switch is not reverse fed, in which case the fuses could be extracted with voltage present on the load side of the fuses. Switches that disconnect both the line and load connections to the fuses are not marked line and load, and as such can be reverse fed. So with that, I'm going to let John handle the more difficult parts of Chapter 5. And the first one he'll be discussing is the wire bending space requirements in 5.1.5. John, I'll pass it back to you.
Thanks, Dan. You covered a lot of very good information, and believe me that those were very important and difficult parts of the chapter to understand. So all of these sections we're going to be talking about are equally important. So as Dan mentioned, the next segment is wire bending space, and you can see a lot of what I would call editorial changes there. The section was given a title, Wire Bending Space, very appropriately for clarity. We revised some of the language at the beginning, changing the to a. This was renumbered 512 to 513, and the word section was deleted into 2 places. That wasn't necessary. Those changes were made in the first draft phase of the work. And then in the second draft, we added terms like what is, the wire bending space, either, and we replaced not smaller with be equal to or larger. We felt that it was more easily understood how to apply the requirement. And then finally, we added the word required to make it very clear about the need for interconnection diagrams to comply with the requirements in Chapter 17. So when we talk about wire bending space, in this case, it is the space measured between the face of the terminal, which is receiving the supply conductor from the machine, for the machine, directly to the wall opposite that terminal. And in this particular slide, you would be looking at the upper right corner where you see a set of terminals, and you see the conductors coming in from the supply. That is the wire bending space. That particular area is quite often referred to as an area where the electrician would make S-bends as opposed to right-angle bends. And I mention this because there's just one table that's referenced in NFPA 79. You see in the slide, it references table that's in Section 430.10b of NFPA 70. Section 4, Article 430 covers motor control, motor circuits. The one table basically covers both S-bends and right-angle bends, and the S-bends are the ones that are more difficult to make, and so the wire bending space is more stringent for S-bends, and therefore the table that's being referenced is the more stringent of the 2 tables that are found in the NEC. This particular table that's referenced in Section 430 is harmonized with the wire bending space requirements in 508A, which is the standard for industrial control equipment. And then reading on through 515, you can see that the wire bending space is determined by the maximum wire size of the supply circuit conductors, where they are equal to or greater than what's required by Article 670 in the NEC, which covers the installation of machinery, and specifically 670.4 paren A covers the sizing of those supply conductors. And then finally, when the wire bending space is based on more than one conductor per phase, the intended conductor size and the number needs to be identified on the interconnection diagrams. So it's very clear that multiple conductors are able to be used, or in some cases required, for wiring to the machine, and then that would certainly affect the required wire bending space. So let's move on and talk about protection of line-side live parts. We've been talking about the wire bending space, and so we're going to be focusing on that same part of the panel. And you can see that in this slide, there's an arrow with the word cover pointing to a section of the panel in the upper right corner, those same terminals I was talking about. That cover basically provides protection against electric shock, because as you know, when you open the disconnecting means, you've de-energized all electrical parts in that panel except for the line terminals of the disconnecting means, and so you need to protect someone from going into the panel, from making casual contact with those terminals. And this particular section was titled Protection of Line-Side Live Parts for clarity. Obviously very clear as to what the requirement is. And you can see it reads, shall be protected from unintentional direct contact by use of insulation or obstacles when the machine supply circuit is in the open or off position and the door is open. And in most cases, the manufacturers of disconnects will provide a shield or some kind of protective device that can be installed over the terminals after the wiring is accomplished. And this would then provide the needed protection. There's also another requirement in the chapter that talks about the location of the disconnect, and specifically that it should be towards the upper part of the enclosure with no equipment installed above it, where the wiring is brought into the enclosure from the supply. That minimizes the amount of area where the live parts are located when the disconnect is in the open position. Just keep in mind here, we're talking about protection from electrical shock. In this particular example here, you still have an arc flash hazard with that disconnecting means open, because you still have live electrical parts inside that enclosure. So we need to be cognizant of the difference between protection from electric shock as opposed to protection from the arc flash hazard. Moving on, let's talk about this next section. This is 5.1.9, titled Machine Supply Circuit Disconnecting Means. Now, you'll notice we've made some changes here. Removing the word isolating, that always seemed to cause some problems, because isolating being different in terms of the way it's defined versus disconnecting, as those terms are applied to a switch or some kind of means to provide disconnection of conductors. You see a lot of renumbering going on at the top. That basically is necessary with the restructuring of the chapter. The term general was removed. We felt that was unnecessary. Connecting to a machine was deleted. It was felt that that was unnecessary, and the term machine was added for consistency in 4 different places. And then finally, you see at the bottom in the exception, we added the words RMS AC or 60 volts DC. I'll get to that in a moment, but let's look at what's going on in this particular section. 5.1.9.1 states the machine supply circuit disconnecting means shall be provided for the following. Number 1, each machine supply circuit. So certainly a machine could have more than one supply, especially if there's a need for different control voltages, different from the voltage of the supply for the power circuits in the machine. Number 2 in the list is each machine supply circuit, and then we added some very important words: to a machine or a number of machines connecting to a feeder system using collector wires and so forth. So it's each machine supply circuit to an individual machine, or you could have a number of machines being fed from one supply. And then finally, with the exception, I mentioned there's a bit of a sidebar there. The committee grappled with the definition of what constitutes a shock hazard. And throughout the document now, we see references to 50 volts RMS AC or 60 volts DC. And I bring this up because there is a bit of a conflict between 79 and 70E. My understanding, 70E uses only 50 volts as the limit, both AC and DC. So there's a disconnect there, and the question is, should 79 harmonize with 70E? And then also we've got NFPA 70, the code, to be brought into the mix as well. So the NEC Correlating Committee has appointed a task group to look at this and to try to see how to bring the 3 documents together. That's 79, 70E, and the NEC with regards to what constitutes a shock hazard in both AC and DC. All right, moving on, let's take a look at this next section in part 1. The term machine was added for consistency, and the reference to section references were changed as appropriate. And then we deleted required by 5.1.9.1. That's no longer necessary. We felt that just added unnecessary confusion to trying to understand the requirements. So what do we have here in this particular slide? We see in 5.1.9.2, each machine supply circuit disconnecting means shall be legibly marked to indicate the equipment it disconnects. Whether it's a panel has one disconnect or multiple disconnects, it's very important to make certain that each disconnect has identification as to the equipment it disconnects. Because if you have multiple disconnects in a control panel, for example, what you're seeing here, it may be necessary to open one of those disconnects but leave the other one closed for maintenance purposes or measuring or testing. For example, you could have a separate disconnect for the control circuit, and you might want to have that disconnect left closed with the disconnect for the power circuit open, again, as I said, to do some testing or measuring or maintenance. And so it's very important then to recognize what equipment is still energized with that second disconnect in the closed position. It just makes sense to know when you have multiple disconnects what equipment they are feeding. So then you can isolate the equipment appropriately, whether you need to isolate all of it, de-energizing all the equipment being fed by these disconnects, or selectively. 5.1.9.3 states, a machine supply circuit disconnecting means shall be marked machine supply circuit if additional disconnecting means are supplied from the supply circuit disconnecting means. And then 5.1.9.4 states where a machine is supplied by more than one supply circuit, a marking shall be installed at each supply machine circuit disconnecting location, denoting the location of all other machine supply circuit disconnects. So in many cases, you may have multiple panels for a machine where you have multiple supplies for that machine, and you need to know where all of the disconnecting means are if you're trying to, for example, de-energize the entire machine. So in many cases, the disconnects are not grouped together, and therefore they may be out of sight of one another. So for obvious reasons, you need to know where all of the disconnects are for a particular machine, certainly when you're doing any kind of maintenance or testing and so forth. So marking those disconnects to denote the location of all the other disconnects is very important and required. And then in this slide, we talk about the machine supply circuit disconnecting means shall disconnect the electrical equipment of the machine, including all control circuits from the machine supply circuit when required, for example, for work on the machines, including the electrical equipment. And then circuits that are not required to be disconnecting by the machine supply circuit disconnecting means shall comply with 5.1.13. We'll talk about that later in this webinar. So the basic requirement is that you should use the same disconnect for both power and control circuits. However, if that's not practical or not possible due to the design of the machine, then you must have a separate disconnect for those other supplies, and we will cover that in section 5.1.13. So now I'm going to pass the program back over to Dan, and he will continue on with part one. Dan, it's all yours.
All right, thanks, John. As you can see, we have, I think perhaps we should have explained at the very onset. I'm kind of monitoring the chat here a little bit, and I'm answering some of the easier questions, hopefully. What we see here is we have two different types of equipment. Okay, we have industrial control panels, and if you look at the slide that I have shown here, the industrial control panel could be just that one enclosure that is downstream of the machine supply circuit disconnect. Okay, an industrial control panel is just a very general term for a a piece of electrical equipment that can't be categorized as something else. And it's typically a standalone type of equipment. You might walk out to your shop floor and you'll see an enclosure with maybe some power distribution blocks, maybe some other branch circuits. That's an industrial control panel. Industrial machinery, and if you look in the definition, the NEC of industrial control panel, what you want to be aware of is that it says it does not include the controlled machinery. Okay, so when we're talking about it, what I'm kind of missing from these pictures here is I'm showing you the industrial control panel. I'm not showing you the associated machine that goes within a lot of these pictures. So, and understand that machine can be very complex, right? You might have, one main panel, and then you might have several downstream panels. The size of the equipment can be, the size of a pallet, or it could be the size of a large industrial floor. So you have to understand what we're talking about. And I'm getting a lot of questions about, how NFPA 79 is enforced. NFPA 79 is really a customer-driven specification requirement for the construction of the equipment. And as you can see, there's a lot more stringent requirements for that, both electrically as well as the safeguards of the machine, which we're not going to get into today. We're primarily focused on the electrical. But, what you see here today is we always, when it comes to industrial machinery, we always have to have a machine supply circuit disconnect. That is not necessarily the case for industrial control panels. There's not necessarily any requirements for enclosure access when it comes to industrial control panels. That really is up to the designer of the equipment, or perhaps the customer specifications that the OEM is building to. So if we look in here, it's certainly acceptable for me to make an industrial control panel without a main disconnect and have that be required by someone else if it's properly marked. So I just want to make sure we have that clarification here before we move on. So let's move on to section 5.1.9.6. And as you can see, this was previously section 5.3.1.3, and this requires the machine supply circuit disconnect to be mounted in the enclosure it controls. Now, obviously, for a variety of reasons, it may not be possible to include that disconnect in the enclosure it controls, or perhaps it may not be desirable. So there is an exception to that. And, one common reason why you might require the disconnect outside of the primary control cabinet is perhaps from a safety standpoint. Here we have a picture of, bourbon bottler one. You can tell where I've been. My mind has been focused during this COVID-19 shelter-in-place type confinement. So here we have a process. It's a machine that bottles bourbon. And maybe from a safety standpoint, they would prefer that they have the disconnect outside of the main primary enclosure. So, and the reason for that might be a couple-fold. One, it might be that when they turn off the disconnect for the primary main controller, everything in that bottom panel is de-energized. They also might have to go in there from a maintenance and troubleshooting standpoint where they have to have proper PPE. And by doing that, if they do have to defeat the mechanism to open that enclosure, if that's required per NFPA 79, they can defeat that and they can go in there, but they know how to dress because the protection is immediately upstream. So perhaps it's that fuse switch, and they can determine the instant energy based upon the arcing current that is available at the equipment and the clearing time of that current limiting fuse switch. So that's the driving force of why we have this exception. But basically, here's what the exception says. So the exception allows the machine supply circuit disconnect to be mounted up to 20 feet away, okay, for the control enclosure provided properly marked, and that's very important to indicate the location, and provided it is in sight of the control enclosure it supplies, readily accessible, and marked to indicate the equipment it disconnects. So as you can see in the first draft, the term machine was added in 7 places for consistency. The section numbers referenced within the text were revised to correlate with the renumbering of the chapter, and former exceptions number 1 and number 2 have been combined into one exception because the enclosure access requirements in Chapter 6 have been revised to permit different options for restricting access. It was no longer necessary to distinguish between machines that are more than 2 horsepower from ones that are not. So we kind of have more general options for enclosure access. And the last thing we did was in the second draft, we added its supplies for clarity. So let's move on to the next section, 5.1.9.7. So section 5.1.9.7 was previously section 5.3.1.4. And I know it looks like there's a lot of things struck out here, but really the change is not as drastic as it looks, okay? So this section covers the enclosure access requirements, okay, for the machine supply circuit disconnecting means. And it requires them to be in accordance with 6.2.3.1. Now, what we did here to kind of show you all the strike-throughs and what actually happened there, in the first draft stage, the text of the opening sentence was revised to reflect the changes made to the enclosure access requirements of Chapter 6. The exceptions were deleted as the concepts they contained were addressed by the committee's actions in the Chapter 6 revisions. The section references 6.2.3.1, which identifies the different options for enclosure access for the enclosure containing the machine supply circuit disconnect. These options will be covered in Part 2 of this presentation and in greater detail in the next webinar covering Chapter 6. So basically, you're going to find we have basically 3 options when it comes to enclosure access for the machine supply circuit disconnecting means. It used to be only one option, and that was interlocking. That has changed. So moving on, let's move on to section 5.1.9.8. So as you have probably figured out here, there's been a lot of renumbering. So this is just a relocated section. 5.1.9.8 used to be section 5.3.1.5, and again, we didn't make any drastic revisions here. We simply added the term machine in 2 places for consistency in the first draft stage, and we added in the second draft stage the word same for clarity. So what does this section say? This section requires the machines with more than one supply circuit disconnecting means within the same enclosure to be grouped in one location and have protective interlocks for their correct operation if a hazardous condition or damage to the machine or work in progress can occur. So in the example you see to the right, we have 2 disconnects. We have what I would call the primary main machine supply circuit disconnect, which is 1. That probably controls the vast majority of the processes that are being controlled for the machine. And then we have a separate machine supply circuit disconnect 2 that perhaps is for maybe it's for electronics or something of that nature. Okay, let's move on to what is acceptable to serve as that machine supply circuit disconnect. And this really is a very, very important topic. There are only specific devices that you can use to serve the purpose as the machine supply circuit disconnect. And I want to stress that I see a lot of situations where perhaps we're using a device that is not suitable for the machine supply circuit disconnecting means. And we're going to point some of those devices out in part 2 of this presentation. So as you can see here, we didn't make a lot of revisions. And again, 5.1.10 covers the type of machine supply service disconnect that was previously covered in 5.3.2. The revisions made to this, basically we just added the machine in one place for consistency, and we revised device. Although we're talking about devices that can serve as the machine supply circuit disconnect, the terminology we should use is the machine supply circuit disconnecting means from a consistency standpoint, okay? And basically we have 6 different options, okay? So the first option is a listed motor circuit switch rated in horsepower, okay? That could be a fuse switch, like you see the 2 top examples. One is an example of a bussmann, what we call our compact circuit protector. That is a UL98 disconnect. And the other is our rotary style version, again, a UL98 disconnect. And that's very important. Whether it's a fused disconnect or a non-fused disconnect, must be rated in horsepower, and it must be a UL98 disconnect. There's a different type of disconnect we'll talk in part 2 about that looks like a disconnect, but it really is a manual motor controller, and there are limitations to where that can be applied. Option number 2 is a listed molded case circuit breaker. That, of course, would be suitable for that. And that's kind of the picture below our compact circuit protector. And then to the right of that, we have an example of an instantaneous trip circuit breaker. And here's the key here. Look how similar those 2 devices look. However, they are completely different devices. And when you use an instantaneous trip circuit breaker, you might also hear it called as a motor circuit protector. That probably is the better word to use because it identifies the type of circuit that is permitted, okay? And as you read here in item 4, that last part of the information is extremely important. That device, the instantaneous trip circuit breaker, or the MCP, is only permitted if it's part of a listed combination motor controller limited to single motor applications. So, you know, this is going to be a very simple machine. You know, you basically have maybe just one load for this machine, one single motor, and I've decided to use the instantaneous trip circuit breaker, which provides the short circuit protection for the motor circuit, as well as the disconnect for the motor circuit. But I have to make sure I marry that with the appropriate motor controller that's been tested and listed for use with that. Option number 5, and again, here's one that I see people misapply all the time, and that's the device. Well, there's actually 2 devices there. It might look like the device on the left, bottom left, or it might look like the device on the right. More typically, it's going to look like the device on the right. One is the one on the left is more of what we call a Type E device, where it's manual protection or manual operation, whereas the one on the right, bottom right, is a Type F device, where it includes the additional contactor for automatic operation. But again, just like the MCP in item 4, that is only permitted in single motor applications. So again, you have a very simple machine here. And of course, the last requirement, the last permitted main disconnect type, is an attachment plug and receptacle for cord connected equipment. So let's move on to section 5.1.11. And again, these were previously covered in section 5.3.3 and 5.3.3.1 respectively. And these sections identify the specific performance requirements for the machine supply circuit disconnecting means. So what does this disconnect have to have? What performance requirements does this have to include? Just covering the revisions, very straightforward before we get into the specific requirements, and this will be actually a two-part slide here, so this is going to continue on the next slide. But the revisions that include: the term machine was added for consistency. The section numbers referenced within the text were revised to correlate with the renumbering of the chapter. The term device was revised to means. Again, that's the proper term to use. The term plainly was removed from before indicates in list item 7. And, plainly is one of those words that we really need to avoid using in code. Saying something that is, having a requirement that it's plainly visible, that really is up to interpretation by the AHJ. And it can cause a lot of issues because what you might feel is plainly visible to you might not be, my opinion, plainly visible. So basically, let's look at the specific requirements. So the first requirement is in number 1. So the disconnect, we have to, that machine supply circuit disconnecting means must disconnect the electrical equipment from the machine supply circuit and have one of open and one of closed position only. So basically, if you look at the picture of the breaker there, next to that, there's going to be an open or an off position in the bottom, and that's required. Whenever you mount a breaker vertically, the off position has to be at the bottom, and the on or closed position is at the top, so that orientation is properly correct. Circuit breakers, instantaneous trip circuit breakers or molded case switches and self-protected combination motor controllers are permitted to have a reset or tripped position between the off open and the on closed position. So you kind of see here in that picture of the molded case circuit breaker, there's a little red circle, and that's where the trip position is. So if that breaker tripped due to an overcurrent position, that's where the handle would return to. Number 2 deals with an external operating means. Example, a handle. So if you can look to the right, a lot of industrial machinery manufacturers, they prefer, although you don't have to use a flange handle, many industrials prefer the flange handle. So what you have there is a flange handle, and that must comply with 5.1.1.2. Now, John's going to cover that later on. Okay. If you look at option number 3, it says be provided with a permanent means, permitting it to be locked in the off or open position by padlocks, for instance, and it must be independent of the enclosure door or enclosure cover position. If I have the flange handle that's shown in the middle picture here, that requirement to be operable either in the with the enclosure door being open or closed, that's very easy. That complies with that requirement. If I look at the rotary style device at the bottom there, it does show the ability to lock it out, which is required. Okay, and that would prevent the second part, when so locked, remote as well as local closing into the local position shall be prevented. But when I open the enclosure door, that rotary style handle loses contact with the shaft. And we're going to have to address that, as John will cover in section 5.1.2, to allow me to operate that disconnect while the enclosure is in the open position. And of course, the disconnect is required to simultaneously disconnect all ungrounded conductors of a supply circuit. So I mentioned earlier that this was going to be a part 1 and part 2 of these requirements. Obviously, we have more to cover. So the requirements, the initial requirements are requirements number 5, 6, and 7. Okay, so we're continuing with those requirements for the machine supply circuit disconnecting means. Again, in this, the term machine was added for consistency, just like previously. Section numbers referenced within the text were revised to correlate with the renumbering of the chapter, specifically chapter 5. The term device was revised to means, and the term plainly was removed before indicates. So the additional requirements include number 5, be operable by qualified persons independent of the enclosure door or enclosure cover position without the use of an accessory tools or devices. So again, if I have a rotary style, I'm gonna need something that allows me to operate that. Often with a rotary style, you have the rotary version of our CCP shown there in the middle. And to allow me to operate that, I typically have an internal handle that can be mounted on the shaft to allow me to operate that when the enclosure door is open. It must be rated as follows, and this is very consistent with the NEC. It must have an ampere rating of at least 115% of the sum of the full load currents required for all equipment that is in operation at the same time under normal conditions of use. We're rated in horsepower, and we already said that. Okay, when we talked about in 5.1.1.10, we talked about a switch rated in horsepower. The horsepower rating must be at least equal to that of which is defined by the table 430.251b of NFPA 70 for a locked rotor current equal to the largest sum resulting from the locked rotor currents of any combination of motors that can be started simultaneously and the full load currents of the remaining motors and non-motors that can be operated at that time. So this is very important. And in industrial machinery, again, we typically have more than one motor being supplied on this machine, and we have to make sure that that main machine supply circuit disconnect is rated to operate and open safely all the motors that might be in operation at the same time. And of course, we must have a voltage rated adequate for the nominal supply circuit voltage. And again, we deleted the term plainly, but it must be a type that plainly indicates whether it is in the off, open, or the on closed position. So with that, I mentioned earlier that I'm going to be passing this back to John. And John, I'm going to give you pass it back to you to cover the requirements for the operating handle.
Thanks, Dan. Let's finish out the remainder of the slides in part 1 of the program. As Dan said, we're going to talk about the operating handle, which is covered in section 5.1.12. You can see some numbering changes there. This material was previously in section 5.3.4, and of course 5.3.4.1 now becomes 5.1.12.1. You can see we made some word changes there. You see the word machine in parentheses, and it never fails. As hard as you try to be consistent, you always overlook some parts of this standard where we could have done a better job. And you can see we're already working on the next edition of the standard. But the word machine really should be there for consistency because we are talking about the machine supply circuit disconnecting means. So with regards to the operating handle, it has a specific limitation as far as the height above the servicing level. For example, the ground floor of a factory where a machine is located. However, you could have a raised platform that's permanent, and then you're allowed to use the level of that platform to determine the maximum height of the operating handle. This ensures the handle and the disconnect itself be readily accessible, and you can see in 5.1.12.2 we address that. We talk about the operating handle being readily accessible with the door open or closed. Dan kind of talked already a little bit about disconnecting means with regard to their location, their construction, their operation, and the different types that are available. Going on, another important requirement is to maintain the environmental rating of the enclosure. Disconnects that are mounted through openings in an enclosure, and then specifically I'm talking about the operating means. For example, the operating handle you see in the top photograph there, the handle is mounted through an opening in the flange of that enclosure. Typically that operating handle would have been evaluated for use in other than a type 1 enclosures, for example, like a type 3R or 4, 4X or 12. So depending on what the type rating is of the enclosure, if you want to make certain that you maintain that type rating of the enclosure, you need to install a handle or any component that's through an opening in an enclosure. You need to make sure that component has the same type rating as the type rating of the enclosure. There are some exceptions where certain type ratings can satisfy that type rating of the enclosure, where the type rating of the handle is different than that of the enclosure. It may be a handle that's intended for more severe applications, for example, a type 4 over a 3R. So you have some opportunities there for a mismatch where you can actually use the handle to maintain the type rating of the enclosure. And then finally, we see not to be restricted with the enclosure doors. When the door is in the open or closed position, typically the construction would be such that when you open or close the door, you're not interfering with the ability to have the handle readily accessible. So moving on, we're going to talk about accepted circuits, and this is covered in section 5.13.1. Now you can see here there's a list of different kinds of circuits that can be accepted, and when we use the word accepted, we mean they're accepted from being supplied by the machine supply circuit disconnecting means. So they can be actually connected to the line terminals of the disconnecting means so that they remain energized. Those circuits and equipment being supplied remain energized with the machine supply circuit disconnecting means open. And in many cases, there is a need for that, and you can see the applications in 1, 2, 3, and 4 where there are opportunities or requirements where you need to have equipment that is connected on the supply side of the circuit disconnecting means. So let's move to the next slide, which is probably more important because the previous slide just talked about what is an accepted circuit. But here we get into requirements for accepted circuits. And you can see they should be provided with all of the following: a disconnecting means, isolating transformer over current protection mounted in an enclosure, either adjacent to or within the control enclosure containing the machine supply circuit disconnecting means. So when you connect on the supply side of the machine supply circuit disconnecting means, you have to go to another disconnecting means. You need to have a means to isolate those accepted circuits, and that's essentially what you're seeing in requirement number 1 of 5.1.13.2. And that disconnecting means can be either in the same enclosure as the machine supply circuit disconnecting means, or it can be in a separate enclosure. But if that's the case, it must be mounted adjacent to the enclosure that contains the machine supply circuit disconnecting means. And then we have a requirement for the line side supply circuit conductors. When they're internal to the control enclosure, we need to make certain that they are separate from and do not share a raceway with other conductors. Obviously, it's very important there to make certain that those conductors are protected because when you have the main disconnecting means open, they are energized. And so that is the purpose of that requirement in 5.1.13.3. So moving on to 5.1.13.4. Again, we're talking about accepted circuits. And we have, in the previous slide, talked about the requirements for protecting the conductors, having a separate disconnect. In this particular section, we talk about marking. And you can see in the list, in particular, item number 1, you need a permanent safety sign, which shall be placed adjacent to the machine supply circuit disconnecting operating handle, indicating it does not de-energize all exposed live parts when it is in the off or open position. And you can see in the picture of the enclosure we see on the right on the slide, we have a label that's blown up to show you the words that are necessary to make it very clear to someone that when they open that disconnecting means that there are live circuits somewhere, and most likely they are somewhere in that panel. And then you see item number 2 in the list, we talk about the need to contain information in the machine documentation, which is required in Chapter 16, information that addresses the importance of recognizing that you do have these accepted circuits and what is the purpose of them and what equipment is contained, what equipment are supplied by these circuits. And then number 3, a permanent safety sign shall be placed on a non-removable part inside the control enclosure in proximity to each accepted circuit, or shall be identified by color. The purpose of this is you need to identify components that are in that same enclosure where the machine supply circuit disconnecting is, so that one knows that those components will indeed be energized when the supply circuit disconnecting means is in the open position. So other than that, just a little bit of renumbering here and then some important word changes for clarity. So moving on, talking more about accepted circuits, we see in 5.1.13.4 where the accepted circuits are not disconnected by the machine supply circuit disconnecting means all of the following requirements shall be met. You see, again, a permanent safety sign shall be placed adjacent to the machine supply circuit disconnecting means, indicating it does not de-energize all exposed live parts. Again, we require a statement in the documentation and then a permanent safety sign, as I mentioned in the previous slide, which is required to identify the parts of the enclosure or equipment that remains energized when the main disconnecting means is open, equipment that would be part of the accepted circuit. And then finally, in slide number 27, we move out of Chapter 5 just for a moment because we want to talk about some other things that are important with regards to accepted circuits. Section 16.2.4 deals with the need for a safety sign provided adjacent to the disconnect operating handles. 13.2.4 deals with identification by color for other conductors. It's important to recognize in the accepted circuits, the color orange shall be used to identify ungrounded conductors that remain energized when the main supply circuit disconnecting means is in the off position. And then there are some exceptions, for example, when the wiring is part of the device purchased and then where the insulation used is not available and the colors required, then some other means of identification of that circuit shall be necessary. Okay, that completes part one. I'm going to turn it back over to Dan, and he's going to get into part two. Dan, it's all yours.
Thanks, John, and I appreciate it. I think I used the color yellow earlier, and I appreciate you not correcting me. I'll correct myself. I know that, as you can see there by that last slide you covered, the color is orange that you need to have. So we're going to move on to part two, additional disconnecting means. I'm going to try to speed it up a little bit because I know we're running short on time. So the part two is going to cover the additional disconnecting means, and we'll talk about the types, operating means, and enclosure access. So let's move on to the first part, which is 5.2 and 5.2.1. And again, those were previously 5.5 through 5.5.3 respectively. Okay, so what we did here basically is in 5.2 we changed the title of the section to additional disconnecting means to clarify that these disconnecting means are in addition to the machine supply circuit disconnecting means. And again, it's not uncommon to have additional disconnects downstream of the machine supply circuit disconnecting, and that's where these requirements are going to address. The revision correlates with 5.1.9.3 that already uses additional disconnecting means. In 5.2.1, the requirement was revised to specify the additional disconnecting means are optional. Again, you don't necessarily have to have there. In the picture I'm showing, I show in one I show perhaps a fuse switch, and the other I show a fuse holder. So we don't necessarily have to have a disconnecting means. It's optional. And that's what we're saying in 5.2.1. The former 5.5.3 was combined with 5.2.1, so even though it shows strike through, it's been harmonized with that. The words "in addition to the machine supply circuit disconnecting means" were added to clarify these disconnects are in addition, again, to the machine supply circuit disconnecting means, and correlate with the revisions made to the section title. The term "isolated" and "when it is de-energized and isolated" was deleted for consistency. In 5.2.2, that was renumbered and deleted section and revised to electrical circuit to machine. In the second draft, the section was deleted as an additional disconnected means are now permitted versus required with the revisions made to 5.2.1. Okay, I alluded to earlier that there was a type of disconnect that is not permitted as the machine supply circuit disconnect. And this is a device covered in 5.2.2, which again was previously 5.5.4. And this section identifies additional devices that can be used for as a disconnected means under, and here's the key thing, certain conditions, okay? The section number referenced within the text was revised to coordinate with the renumbered chapter. And we basically have two types of devices that can be used in addition to the typical machine supply circuit disconnected means discussed earlier. So the first one is what we call a manual motor controller, and that's the picture to the right there. And as you can see, these look just like a disconnect, right? And it's often confused. The one on the right is a manual motor controller. Those are those typical MMPs you see that are listed to UL 508. And then on the right, we have what we call a non-Q switch. And those non-Q switches are actually, they look like a switch, but they're listed as a manual motor controller. And by definition, a manual motor controller can only turn off and on a motor. So these might be suitable for the operation of a motor, but they may not be able to be served as a motor disconnect unless, and here's the key thing, located on the load side of the last short circuit protecting device branch. And that really is more of an at the motor in that application. And the last one, details system isolation equipment, is permitted as well. Okay, moving on to section 5.2.3. So again, 5.2.3 was previously section 5.5.5, and it just gives some additional requirements for that additional disconnecting means. So well, what do we do here? So basically, in the first draft, we revised section 5.2.4 and the term each to other. In the second draft, the term other was revised to an for consistency. So again, we're making changes to ourselves. The term isolation devices was revised to additional disconnecting means for consistency. And 5.2.3 was revised to 5.2.2 due to the deletion of the previous 5.2.2. The term in isolating was revised to a disconnecting means, a disconnecting for consistency. And basically we have the requirements for operating the means of the additional disconnect, and these include, one, it must be readily accessible. It must be within sight of the part of the machine requiring disconnection, again, 50 feet, and I can see it. Readily identifiable as a disconnecting means and marked to identify the equipment that is disconnected. So here we have, you know, that disconnect that's there on the left in the panel is for motor 1. And then for other than attachment plugs provided with permanent means for locking in the off position. So, you know, our CCP has a lockable mechanism that can be used to serve that purpose. And last, I'd like to talk about enclosure access in 5.2.4. I'm waiting for my screen to refresh here. Okay, so in 5.2.4, we cover enclosure access. And it really is enclosure access for enclosures containing disconnecting means. And again, just like with the machine supply circuit disconnected means, we have to comply with 6.2.3.1. So in either case, whether it's just a disconnect downstream of the machine supply circuit disconnected means, or whether it's a additional disconnected means, we have to comply with 6.2.3.1. And for the purpose of this, I'm going to briefly talk about that. So basically, we have three options. If the If access to the live parts require the use of a key or tool, basically we can have the parts need to be protected from live parts from the 2-inch spear, which is basically back of the hand protection. And we have to have a safety sign that John talked about previously in 16.2.4. So an example of that might be a panel board. To access the live parts of the panel board, you're going to have a key or tool to take off that trim. Number 2 is the classic enclosure interlock with the enclosure door. And I have an enclosure interlock kit there shown to the right. And the third one does not require the use of a key or tool, where all live parts inside operating at more than above 50 volts RMS or 60 volts DC are separately enclosed or guarded such that there cannot be any contact with live parts. So, you know, it's kind of difficult to see there. But what I intended to show you there is that if I was to open that enclosure on the bottom, essentially there's a piece of plexiglass which would provide the required protection and not allow me to contact any of those live parts in there. So that's kind of how we would denote that. So in interest of time, I think, John, I've left you about, I don't know, 9 minutes. I apologize. Hopefully you can bring it home from here.
Thanks, Dan. Well, as I mentioned at the top of the program, part 1 was the most important part of this webinar. It contained the most important material relative to the machine supply circuit disconnecting means. But part 3 is important to a certain degree, and we're going to go through the remainder of the slides here rather quickly, but I think you'll quickly see what this is all about. So when we talk about means for removal of power, essentially we're talking about what's in section 5.3. And it provides the requirements for the means of removal of power from preventing unexpected startup. Although the machine supply circuit disconnecting means may be used to de-energize the electrical equipment to allow work to be performed in a de-energized state, other disconnecting means used for the purpose can be located downstream of the machine supply circuit disconnecting means. And so what's in 5.3, basically prevention of unexpected startup. That's the purpose of having these additional disconnecting devices. Permitted methods. What kind of disconnecting devices and how are they allowed to operate? How do you deal with failure of components that may not be so reliable to provide disconnection? And then other means that are acceptable for removal of power. So when we talk about removal of power, 5.3, 5.3.1, previously it was 5.4 and 5.4.1. Now we've got a title to 5.3 very clearly stating means for removal of power for prevention of unexpected startup. Why are we concerned about unexpected startup? Well, if we're performing maintenance, we want to make sure that the machine doesn't all of a sudden start to go in motion, possibly putting personnel in jeopardy, personnel working on the machine in jeopardy of being injured. So when we talk about the removal of power, the means shall be appropriate for the intended use, shall be conveniently located, shall be readily identified as to function and purpose, and then finally provided with a permanent means for locking in the off position only. So those are just some very general terms. So what do we allow with regards to the means for removal of power? Well, in 5.3.2 and 5.3.3, we basically identify what is acceptable. And of course, the machine supply circuit disconnecting means is the obvious choice and probably the most common choice. But we can certainly use other devices. As you see in item number 2, there are additional devices conforming to 5.1.10. For a good example would be the manual motor controller, suitable as motor disconnect, that must be connected on the load side of a branch circuit protective device. Number 3, you can have other means, like, for example, a contactor can be used to isolate a circuit. Other means are covered in 5.3.3 and 5.3.4. So if we look at 5.3.3, we see other means. When they are used, there is a very major concern there in that a single failure of any of the components that constitute those means shall not result in an inadvertent or unexpected startup. For example, if you were using PLC, you would have to make sure that PLC would be a type that would be a safety device to be able to provide reliability in terms of making the means of removal of power safe and insured if you do have the need to work on a piece of equipment. So that basically covers what's in part 3, and I'll turn the program back over to our moderator, Shannon. Thank you, Shannon.
Thank you, John, and thank you, Dan, as well. We have only about 4 or 5 minutes, so let me go straight into some of the questions from the audience. First question, does the machine supply circuit disconnect have to be in a separate enclosure from the main control enclosure?
I'll take that from you, Shannon. So this is pretty interesting. I mentioned, I don't know if you guys know, we're actually going through a review of well, the NEC is entering another cycle to go through for the NEC 2023 revision, and I happen to see if the public inputs that have been submitted are now can be seen online, and I know there was a public input to require industrial control panels to have a separate disconnect exterior to the main control enclosure. So to answer your question directly, this is not required, but it is permitted per 5.1.9.6, provided not more than 20 feet away from the main control enclosure. The main control enclosure is marked to indicate the location of the main supply circuit disconnecting means, and the machine supply circuit disconnecting means is in sight of the main control enclosure, readily accessible, and of course marked to indicate the equipment it disconnects. And again, as I talked about that, the practice of this is really for safety reasons for the people working on the equipment.
Thank you, Dan. In the interest of time, because we only have 3 more minutes and I do not want to run this webcast over, there are a lot more questions from the audience. We will have Dan and John answer all of those questions, and we will send them out to you in a PDF document in the follow-up email later this week or next week. So this will conclude today's webcast. Don't miss our next 2 webcasts on November 5th and 19th. They will cover protection from electrical hazards and overvoltage protection, respectively. You can register for those 2 webcasts in the same place where you can view any of our webcasts on demand after the live broadcast, and that is through the portal. If you click on any of the links in your email where you enter in your email address, that's how you gain access into the portal. And again, all of this will be explained in the follow-up email later. On behalf of both UL and Bussmann, thank you so much for your time. Have a wonderful rest of your day.